Hi everybody. So we've got a little bit more material to cover, and I was planning to do it this week, but they let me know on Monday that class was going to be canceled today. So I had to adjust, and I checked in with my people here at the college, and they said that this would be the best way to do it. So we're going to talk about modules 21 and 22 through this video, and I know that it's not ideal, but it's where we're at. I wasn't planning to have 5 or 6 days taken out of my schedule this semester, but that's okay. Modules 21 and 22 really aren't so bad. They introduce a couple new formulas, but if you're familiar with the stuff that we did in modules 19 and 20, you should be just fine. And if you haven't done modules 19 and 20 yet, I would strongly suggest that you get into those before trying to do any of this stuff, because it will be a lot easier on you if you do. So let's start by an overview of what these sections include. So we got a lot of numbers back here. I'm going to ignore them for right now. So what this section includes is, let's say that we take 2 different samples from the same population, and we'd like to compare them to each other and figure out if the difference is statistically significant or not. So it's like if we took a bunch of, I don't know, Whataburger employees, and we took a bunch of Rite Aid employees, and we wanted to compare their salaries against each other and see if they're different at all. Now, as you know, it's not good enough for just 2 numbers to be different. They have to be different in a statistically significant way. So we're going to talk about that as well. But for 21 and 22, we're actually comparing 2 sample populations to each other. Something different. So with these, we're going to go about it in the same way that we learned how to talk about proportions first, and then we talk about statistics that involve the mean and standard deviation. So the numbers are just a little bit more complicated. They're not bad. Let's get into it. So first off, P1 and P2, they represent proportions from one sample and another. And our null hypothesis says that we want P1 minus P2 to equal 0. So our null hypothesis is that we've taken these 2 samples, they were randomly selected, everything's good, so their proportions should be the same. So if they're not the same, then we have to accept our alternative hypothesis, that is, if it's statistically significantly not the same. And our alternative hypothesis takes on the form of P1 minus P2 is greater than, less than, or not equal to 0, depending on our situation. Okay, so we're given 2 different samples, and we have to calculate a few numbers in order to make sense of them. The first number that we need to calculate is called the pooled proportion. So the pooled proportion, P hat, that little caret on top of it, is equal to x1 plus x2 over n1 plus n2. And that's when we have x1 and x2 as successes in samples 1 and 2. Remember, when we've got a binomial random variable, a success just means a yes. So like if you had 23 out of 50, let's say college students that use cell phones, 23 would be the number of successes. Then it's divided by n1 plus n2, which is the size of our samples. So what this is doing in kind of a convoluted way is it's taking 2 different samples and kind of mashing them together to figure out a standard deviation and an error and everything. Well, in this case, we're not looking at really a standard deviation until we get to the z-test, but you know what I mean. So we're crashing these 2 populations together, and once we get that, we can get the error. This should look similar. Remember that we had error calculations of like sigma over root n, or p times 1 minus p over n. This is just a variation of that. So to get our standard error, it's p hat times 1 minus p hat over n1 plus that same thing over n2. So once we get that standard error, that's how much approximately the data should vary. Our standard error comes into context a little bit more when we actually do the z-test on it. So for the z-test, we take p1 hat minus p2 hat. That's the proportion in population 1 and the proportion in population 2. We take their difference and divide them by the standard error. The standard error is the error that we should expect with the two populations. Because remember, when you take two samples, even if you take them randomly and you do everything right, their numbers are going to differ just because of how random samples can vary. Who knows, we might pick one sample really, really strangely and the other one could reflect our population pretty well. So we take the difference of our two proportions and then divide it by our error. And what that gives us is how many standard deviations above or below the mean these two proportions are. So if the two proportions are like -5 standard deviations from the mean, that means that yes, something is going on between the two samples. So a good example of this might be like, I don't know, if you looked at percentage of people that could lift over 300 pounds, and one of your sample populations focused on people that lift weights 5 days a week, and the other one focused on people that work out 5 days a year. We should expect the difference in proportions between those populations to be not only different, but quite different. And that'll come out when we run our data. All right, so I hope you're following along in the notes. I'm gonna get rid of this and then we will do an example, show you how all this works.